CityJS Belgrade, welcome. I wish you a warm welcome to today's talk. First of all, I would like to thank all of you for coming today to hear me out, hear other amazing speakers out. I would also like to thank Dylan and everybody from the Half-Stack organizing team. Thank you so much for supporting this event, and of course our amazing sponsors. This couldn't be possible without them. So first, can I get a big round of applause for everybody that I just mentioned? Okay, great. Little energizer right at the beginning. Now we can start. Today we're going to talk about something called Web API, but before we do that, we need to go to some JavaScript basics. Can anybody tell me what this code will log? 132. That is correct, sir. May I ask you, how do you know that? you just went right into it, right? Sorry, I didn't hear you.
Life experience.
Life experience. Okay, that's a good argument. You just sense it, right? Okay, anybody else? Maybe some other answers? Yes, please go ahead.
Set timeout will push out the console log from the stack, so it will wait for the first and basically third console log to execute in the stack.
Okay, that's pretty correct. What you basically just said, let's visualize it a little bit. You said correctly, first console log will go to the stack and will execute immediately. Set timeout will go around somewhere and wait for a bit for amount of millisecond that we put as a second parameter, right? And the third one will be logged again. Then once it's finished, staying at somewhere in the background, it will go to the event loop. Event loop will check for the stack if it's free. If it's free, then we go and log that one. But the question is, where is set timeout waiting? And that is Web API. So Web API and set timeout is not actually part of the JavaScript language per se. It's part of the environment in which we execute JavaScript code. In our case, on front end, that's the browser. And the Web API is standard that provides all of those, let's say, functions and APIs that we may call in the browser, right? Question for backend developers. Any backend developers here, maybe? Okay. Do you work Node.js, maybe? Question for you. If you run this code in the Node.js environment, where does set timeout go? That's Node API. So that's the environment in which you execute the code on the backend, right? And that is Node.js. That's why, because of that, we couldn't write backend JavaScript code before. Now we can, because we have environment to do that. And environment in the client side is the browser. And if you're a bit curious developer like I am, Nemanja just told us how important that is. I completely agree. And if we go to Google and type set timeout, we will see that the set timeout is part of the MDN Web API spec. So that's how we know that it's part of the environment in which we execute code. Okay, if we click here in the navigation menu, we can see that there are actually a lot of these APIs provided by the browser. So anybody wrote like a file upload component anytime? Yeah, most of you probably did. If you send a request from the browser, if you use local or session storage, all of those functionalities are provided by our browsers. Okay, so we may conclude that the Web API is kind of a collection of all of those interfaces. A little bit about me. When I was in high school, I always wanted to study psychology. So today I'm working at my dream job at Vega IT as a development lead, which is a position where I help others other teammates their careers growth. I teach them not only technical stuff, but also a lot of soft skill stuff, how to communicate with a client, how to estimate the tasks, how to deal with stress and time management, and so on. My name is Nikola Mitrovic, and these are my highlights of web APIs for you for today. Okay, let's start with the first example. I will sit, why not? Everybody else did, so. Okay, let's say we have a page like this, and once we scroll a little bit, we can see that there is something in the bottom left corner. We can see a little astronaut, and once that astronaut is fully visible, he says, "Hello world." We scroll up a bit. Once it's not fully visible, message goes away. We scroll a bit down. Once astronaut is fully visible again, he again says, "Hello world." Okay, how did we manage to do this? There is an API called intersection observer, which basically says if element is visible or not, if it's intersecting the viewport or not. A little disclaimer, the examples that I built are built in React. Is this? Sorry, Mike. Okay. Test. Oop. Coincidence? I think not. Okay, but basically you get the point. So I built those examples in React because simply I'm most comfortable with the ecosystem, with the library and so on. That doesn't mean that you cannot apply all of this in your favorite framework or library. If you use Angular or Svelte or Vue.js, it's all applicable because it's part of the environment in which we run the code, and all of those run code in the browser. Thank you. It's a little bit different now. Test. Okay, cool. If we use React for building these examples, and let's say we have a hook called useVisible, the code would look like this. Do I need to zoom it a bit? Can everybody see the code a bit? Okay. Let's try it out, but sorry, I cannot zoom. I thought it could.
Never mind.
Okay, thank you. So we have a hook called useVisible, and we pass an element as a reference. That is that astronaut reference element that we want to observe. And there are some options, configuration options for the intersection observer. One of those, that is an object. One of those parameters for the object is the ancestor of the target. If we pass null, then we observe element in reference to the whole viewport, as we've seen in our example. We can put a root margin around that intersection, so if we need to catch that intersection a little bit earlier. And we have a threshold that is a value from 0 to 1. So basically, if we pass 1, we're saying we want our element to be fully visible. So we can even say when it's visible by half, then we can trigger that intersection. We have a state, like is visible or not. And then we initialize intersection object. Inside of a callback, we would get entry object. And on that object, we have is intersecting property. What has left to be done is then to observe that reference. And that's basically it. And then we return that true or false. That example with astronaut was really cute and nice and whatever, but probably you're wondering how can we use this in some real-life applications, real-life examples. We could lazy load images with this, so we don't have to load everything at the initial loading of the app. We can offload and load only that we need at the moment, and then while we scroll once the section is visible, then we start downloading the other assets. We could create infinite scroll lists, So for example, if we scroll a bit down, then we have an element which represents the end of the list. Once that is visible, we trigger the next request, and so on. We could defer some animations. We don't need to run some animations if they are not visible on the screen, and save computer power by doing that. And one of the things that we always have to consider with using some of these APIs is browser support. Not all browsers are in pace with the implementation, but all they have to comply to this standard, right? In this case, all major vendors are implementing this API, so we're cool and we're good to use it. Okay, let's go to another example, but before doing that, I'm just going to do one thing in my personal preferences. So note that my laptop is not on the charger, and I'm going to say if there is inactivity on my laptop for a minute, then turn off and save the computing power, save the battery power for my screen. But we're gonna see about that. Okay, you may notice at the beginning I didn't talk about myself too much, but I have a minute to spare and now it's my time to shine. Yes. My favorite country in the whole world is Italy. I really like to travel. And once I go to Italy, I enjoy everything, you know, the culture, the buildings, the cities. And I don't know what's about this, but it's so fun to speak like this. So much passion in just that one gesture. One of the things I like most about Italy is, of course, their cuisine. So once I get home from work, I like to prepare some recipes from Italy. Then I go to a website with a list of a recipe. Then I put my phone on the kitchen, follow the recipe, but after a minute or so, my device turns off. But in this case, it didn't turn off, right? Although I set it to turn off after a minute of not doing anything, right? Okay, how did we manage to do this? There is an API called Screen Wake Lock API, which will prevent device to lock screen, even though we have even though we specifically told the device to turn off the screen. So we go against that system preferences on our device. It can only work if the document application is visible. And if we have a hook in React to do this, here our situation is a little bit more complicated. First, we pass that toggle that said I'm cooking, don't touch my screen, preserve it. And if we pass true, then we request wake lock sentinel. What that will do is we have a navigator object, then we have a wake lock object, and then we request the screen. And then we have to put that in a reference. Why? Because this promise returns a value, and we need to clean exact that value. If we put it on the state, it would get lost. So we need to put it in a reference and then reference that reference exactly and clean it up once we try to remove the lock. If we try to remove it, then we need to call the release method on that reference. And like I said, we need to put that reference to null, and then it will work. It won't work otherwise. Okay, again, use cases. When you're reading an ebook, when you're presenting to the audience, so which I did, when you're following your favorite recipe from Italy, when you're using map navigations and you're driving maybe, or if you're scanning QR barcodes. Browser support in this case is a little bit different. Okay, so Chrome engine vendors support this, Mozilla doesn't. And for the Safari, this means that it's in experimental phase. So they're getting there. They have some implementation in order, but not quite at the moment. One more thing to consider with this API is different devices. So I couldn't make this working on my iPhone, no matter what I did. I think it has something to do with the fact that the Chrome on iPhone is just like a skin for the Safari. They use WebKit under the hood. So probably that's maybe one of the reasons, but also they have some updates regarding the API itself for the devices. So that can be a little bit tricky. Okay, moving on to the next one. Just a sec to start. Yeah, exactly. Thank you. Thank you for that info. Okay. Here we have an example of svemirko.rs. Serbian people are smiling, but svemirko, roughly translated to English, means spaceman. So it's a little bit futuristic app where you go to this web app a few thousand years in the future, and in the backend we're communicating with the NASA's API, which retrieves us the list of all habitable planets. And now we can go and search for some planet, and I don't know, let's say TOI 1136G, sounds amazing, always wanted to go there for a vacation. Then we can reserve a flight. After some time, that request is a little bit long, but it works. But what if we're on slow network and we're trying to reserve a flight, but after some time it's taking too long and we need to detect that and provide some user message. Note that it's not only about the duration of the request, but it's also reacting to the network changes. So we may move the message or display some kind of different message, like hang on, we're going to get right back to you, if fast network kicks in again. Okay, you may suppose there is a network API for that, which provides information about the system connection. And also it can detect connection changes. In React, if we have use network hook, for example, sorry for that, we have this little bit went off, sorry for that, but we have a use state, like a state is fast network or not. We need to check in the navigator for the connection object. I'm going to get right back to that. Why is that important? And if we do, then we can, from that connection object, extract effective type property. Now that property may have these values. So we have slow 2G, 2G, 3G, and 4G. So if it's a 4G, then we say it's a fast network. If it's not, then it's a slow network. And we set that to the state like true, false, and that's it. And we return that. Also, we could add event listener change to that connection object and watch for the changes that I just showed you. Some of the use cases, of course, like notification to the user, reacting to those changes, or preloading large resources. So that might come in handy if you're doing some kind of performance optimizations and so on. Again, browser support for this, not so great. So that's why we needed to check for the connection object inside of a navigator. If it's there, then we have support for it. If it's not, then maybe we need to think of something else. Okay. And one more. Again, we have a Svemirko example. I'm just going to zoom this in so you can see it. We just show some of the network effective types, but you may notice that there was one type missing, and that is what if we go offline. Doing offline applications is pretty much essential in these days of web development. So if we hover this link, right? Sorry, that's a bit of caching issue. Sorry. This often happens because I have a service worker in the behind. Let's try like this. Okay, and then we go offline. Something's not right. Just, sorry, give me a sec. Yes, that service worker interfering a bit, but let's empty the cache and start reloading again. Okay, and then we go offline. Okay, now should be good. Once we're hovering of this button, it triggers a request. So it's also kind of a performance optimization. Question for you, what would you expect in the network tab if application goes offline and you try to send a request? Anybody idea, maybe? Sorry? Yeah, in the network, sorry? Yeah, it's red, and it showed in the network tab as failed. So you try to send a request, a browser figured out we're offline, right? And the network request failed. But in this case, we didn't experience that one. And once we go back online, okay, there's something happening here. We're sending the request. It takes a bit long, and once it's finished, we get another event. If we go to the application tab, and there is something called background sync, you may notice once I hovered over that button, we triggered the registering event. Once the request, once we went back online, another dispatch event was triggered, and once request was finished, we had a finished request. Okay, so how did we support this? There is a background sync API, which basically provides you a way to detect if the application is offline and do some task in the background without interfering the rest of the flow. So we don't need to have failed network request in the network tab. Our application doesn't need to crash. We can do some things in the background. This is the component that we previously had. We had that link. Once we have hovered over that link, we registered a background sync. On the navigator, there is a service worker, and there is a ready object. So that's how we registered that background sync event. And we register a task by a tag name, because we might have multiple tasks doing different things. So we can send out multiple requests, doing some kind of different stuff based on a tag name. Okay, and once we are in the service worker, we add the event listener sync, and we listen to that tag or that task based on that name. Use cases, of course, offline capabilities and improving some of the UX, or maybe sending an email into the background once we go offline or whatever. Browser support for this one, again, not so good, but we're getting there, so keep it hold on. In the previous example, if you wondered, once we go back online and we're inside of a service worker, how we can, once we're back online, we send a request, we get some data from the API, how we can provide those data back to the component. Anybody, maybe an idea?
Some messages bus.
Okay, some kind of a message bus, you're right.
You can send from service worker to all clients.
Yeah, that is correct. There is a message bus, there is a post message method. but I was referring to a broadcast channel API. So there are multiple ways to do that. You're correct. But one of those ways is using by broadcast channel, which basically is allowing you communication between the same contexts, which means if the application is in the same window, same tab, same frame, same iframe, you can pass on information from, in this case, from a service worker to your component. And it goes both ways. So how do we do that? We connect to a channel. We create a new channel. We post a message, and we can pass on the object. The good thing is that it is using something called a structured clone algorithm, so we can send deeply nested objects and whatever structure we might need. And in our component, we subscribe to that very same channel with the same name. And we listen to on-message event. And that's how we get those data. Again, use cases, detect some of the user action, or send messages between contexts. Browser support in this case, sorry, all good. So we're good here. Because we have a very limited time today, and there are a lot of APIs out there, I just picked highlights for you for today, but I hope that I interested you enough to go and research on your own. Some of the hints I will give you right now, some bonus points. There is a beacon API, could be useful for analytics if you need to send a request and you don't care about the response. There is a web speech API to detect your speech and give you some diagnostics about it. There is a web share API, so we can share content between different devices. Geolocation, of course. There is a page visibility API, which figures out if the whole page, whole document is visible, not any element in particular. There is a background fetch API. If you need to download a huge resource and you go offline, you can put that in a service worker. And there is a very, very cool a new one called web authentication, which means that soon we're going to have passwordless future. So we don't need passwords for anything. We could log into web application by just Touch ID or face recognition or USB key or something like that. So long passwords. And some of the takeaways. We're seeing that there are some challenges with using some of these web APIs. We don't have support for all APIs in all browsers. Some of that support is experimental. Sometimes we have to watch out for the device support. But in general, why should we use this? Why should we adopt this mindset of using web APIs first and then going maybe to some library to figure out some problem? Because it's standardized code, it's standardized code, it's standardized code. I probably could not stress enough how important this is, especially these days when we just heard today when new framework is coming out every 2 weeks or whatnot. So this is like a single source of truth for everybody. If you build file upload component, I guess 5 years ago, I could bet that it's still working. If you use a library to build an infinite scroll list, maybe it's working, maybe not. Some of these APIs, most of them are pretty easy and straightforward to use. And we can increase performance. Like I mentioned, if we don't need library for everything that we do, if there is a support in the browser for something that we might need, we can use those APIs first and build our own custom code. The bundle size of our application will be smaller. So we don't push a large amounts of JavaScript to the servers and through the internet out there. And we can increase performance by that. With great power comes great responsibility. Anybody knows? I'm sure Daniel knows, but any of you who said this? Yes? Uncle Ben from Mr. Spider-Man. Congratulations. Yes. So I got this kind of power today to stand in front of you and talk to you. So I felt like it's my responsibility and my obligation to come here today and say this. And there's nobody to stop me now.
Do your thing.
Thank you. I wanted to talk about a little bit about our planet. Okay. I see some of the 404 not found faces. Like, what? Yes, our planet. Like I said, internet is consuming 21% of the electricity. If we create large bundle sizes of our apps and we push them to the servers, and those servers are spread across the globe. There are a bunch of computers put in the data centers, and those old computers are plugged into electricity, right? And they use power. If we ship less JavaScript to the internet, then we would use less energy. We would be more energy efficient. Luckily, there is a very cool app called the website Carbon Calculator, which can do all of these things for you. So please go there and check your website, your application, how green you are. This planet is our home. We only have one home. And I would really, really hate if we had to use Mirko to run for our lives and not go to enjoy ourselves on some exotic planet. So please take care of our home. Let's do it together just a little bit. It doesn't have to be anything special. But if we all put a little bit effort, we can produce all together great results. Please be kind to our home, because if we don't, if we choose not to, well, then one day might be too late. Thank you so much for coming today.